Okay, Assalamualaikum and hello everyone. So today I'm going to discuss tutorial question chapter 1, simple harmonic motion. As in for question 1A and 1B, you can get the answer from tutorial notes or from my slide because it's a definition and properties question. Same goes to question 4A where you can get the answer from your tutorial notes book or from my slide. And for question number 2 and number 3, we already discussed during our Google Meet session. So now I'm going to discuss question 4B. Okay, let's start. The displacement of an oscillating object as a function of time is shown below. Okay. So we have a displacement time graph. And from the graph above, determine for this oscillation the amplitude, period, and also frequency. And then the equation of displacement as a function of time. So as you can see from the graph, it is a sine graph and a positive sine graph. So the equation should be x equals to a sine omega t. Okay, now let's look. What is the amplitude from the graph? We know amplitude is maximum displacement. So this is amplitude. And one cycle, we can get p period. Okay, now, but from this graph, how many cycles? So from this graph, we have one cycle and then we have another half cycle. So in total, we have 3/2 cycle. Okay, 1 plus 1.5 is 3/2. Okay, now the amplitude, we do one by one. So the amplitude is the maximum displacement, which is 30 centimeter or 0.30 meter in SI unit. So what about the period? So the period is the time taken divided by how many cycles. So the time taken is 1.2 second divided by 3/2 cycle, which will give you 1.2 divided by 3 times by 2, which will give you the answer of 0.8 second. What about frequency? We can find frequency by using this formula. Frequency equals to 1 over period. So 1 divided by 0.8, which will give you 1.25 Hertz. Okay, we are done with question number 1. Let's look at question number 2. The equation of displacement as a function of time. So as we can look from this graph, it is a sine graph, positive sine graph. So x equals to a sine omega t. And we know our amplitude. Our amplitude is 0.30 meter sine our omega. We don't know our angular frequency or angular velocity, but we can find for it because we know our period. We can use this formula, omega equals to 2 pi over t, or we can use omega equals to 2 pi f. Both will give you the same answer. So the period is 0.8, which will give you 2.5 pi radian per second. So 2 pi 1.25, which will give you 2.5 pi radian per second. Okay, now we already know our angular velocity, or known as angular frequency as well. So just substitute 2.5 pi and t. So this is your equation of displacement as a function of time. We are done with question number 2. Alright, but am I done with question number 2? Not yet, because you need to write where x is in meter and t is in second. Very important, because they wanted to know your x is in meter or in centimeter or in millimeter. So it will be suggested to use in meter, SI unit. Okay, we're done with question number 4. Now let's look at question number 5. So in an engine, a piston oscillates with simple harmonic motion so that its position varies according to the expression x equals to 5 cos 2t plus pi over 6, where x is in centimeter. We have to take note, very important, whether it is in centimeter or meter, and time is in second. And then the question asks, at time equals to 0, find the position of the piston, its velocity, acceleration. Then finally, we need to find for the period, and amplitude of the motion. Okay, now, in your book, the question is different. Suppose it's supposed to be pi over 6, but in your book it's 6 pi. So please change it to pi over 6 because this is the correct question. Okay, next, the position of the piston. Okay, so we need the position of the piston we need to find the position of the piston at time equals to 0. Okay, now let's do this. So we know the expression is 5 cos 2t plus pi over 6, right? And then we just substitute our t with 0. Okay, now let's substitute our t with 0. So we will get 5 cos 0 pi over 6. And when you press the calculator, you will get your answer 4.33 centimeter, or x equals to 4.33 times 10 to the power of negative 2 meter. So when you are finding for your answer, you must make sure your calculator in radian mode. Okay, not degree. Please change your calculator to radian mode when you're finding. Then you put this equation in the calculator, so you will get the answer. Now, next question is velocity. How are you going to find it for its velocity? Okay, now we know instantaneous velocity is dx over dt, the equation. So now we substitute our x into this equation, which will give you d over dt 5 cos 2t plus pi over 6. Salin balik sahaja. Okay, now as I say, just bring the 5 to in front because we cannot differentiate 5 respect to time. We only differentiate cos 2t plus pi over 6 respect to time. Okay, now when you differentiate cos, what will you get? Yes, you will get negative sign. So, your 5 salin balik. So, negative 5. And then differentiate cos akan dapat negative sign. So, negative sign. And then salin balik 2t plus pi over 6. Now, when you differentiate 2t, what you will get? You will get 2. So, bawa ke depan 2. So, you will get your velocity. The equation is negative 10 sine 2t plus pi over 6. Okay. Now, are we done? Not yet. We need to find for velocity at time equals to 0 second. So, we just substitute our time with 0. So, when you substitute our time with 0, it will give you answer negative 5 cm as negative 1. Why is in cm? Because the expression we're using as is in centimeter, but we can change it to meter per second, which will give you the answer of negative 0.05 meter per second. Okay, so we are done with question A, question B. Now we are going to look for question C. Question C, it asks for the acceleration. So we know the formula for instantaneous acceleration is dv over dt. Do we have our v? Yes, we have the expression for v, which is this one. So we substitute v with this expression, which we get d over dt equals to negative 10 sine 2t plus pi over 6. Now, like I say, we bring 10, negative 10 to the in front because we cannot differentiate respect to time, but we can differentiate sine 2t plus pi over 6 respect to time. Okay, when you differentiate sine, what will you get? Yes, you will get cos. So, salin balik differentiate sine akan dapat cos. So, cos 2t plus pi over 6. Nampak tak? Ini kan 2t. So, you need to differentiate 2t as well. So, differentiate 2t, kita akan dapat 2. Letak ke hadapan. So, you will get negative 20 cos 2t plus pi over 6. So, now, are we done? Not yet. Because the question asks the acceleration at t equals to 0 second. So acceleration equals to negative 20 cos 2 0 plus pi over 6, which will give you the answer of negative 17.3 cm as negative 2 or negative 0.173 meter per second squared. Yep, we are done with question C. Now let's look for question D. Find the period, amplitude and amplitude. So from here we can find for the period and amplitude. How are we going to do that? Okay, now let's look. Okay, the amplitude. So the amplitude, as we know, we can compare. The equation given is x equals to 5 cos 2t plus pi over 6. Right. So we know this is the amplitude. So the amplitude is 5 centimeter or 0.05 meter. What about period? What about period? So we know, right, omega equals to 2 pi over t. Now you can substitute your omega with 2. So 2 equals to 2 pi over t. And t equals to 3.14 second or t equals to pi second. Add 1. So you just rearrange this equation. You will get 2 pi divided by 2. You cancel your 2. You will get pi or 3.14 second. Question 6. The graph shows the variation in displacement with time for an object moving with simple harmonic motion. So you have displacement time graph. Okay, let's look at the first question. What is the frequency of the motion? Okay, we can find for the frequency by looking for the period. So from the graph we know 1 cycle. So period. So our period here is 2 seconds. And we can find for frequency by using this formula 1 over period. So 1 over 2 equals to 0.5 Hertz. So we're done with question A. Let's look at question B. The maximum acceleration of the object. So for maximum acceleration, we can use this formula, which is amplitude times omega square, angular frequency or angular velocity square. But do we know our amplitude? Yes, we know our amplitude. Our amplitude is from the graph. We can get from the graph, which is the maximum displacement, which is 10 times 10 to the power of negative 2 meter. What about our omega, our angular frequency? Can we look for it? Yes, we can use this formula, which is angular velocity equals to 2 pi over period. So we already know our period. Our period is 2 seconds. So this will give us pi radian per second. So we already know our amplitude. We already know our angular frequency. We just substitute into maximum acceleration formula. So 10 times 10 to the power of negative 2 times by pi squared. So you will get the answer 0.987 meter per second squared. Alright, we are done with 6B as well. Okay, next question. Question 7. An object is attached to a spring. An object is attached to a spring, is pulled down. Good. So there's an object attached to spring. Okay, for this kind of question, it's better for you to draw. So it's easy to you to understand the question better. So an object is attached to a spring, is pulled down 20 centimeters from the equilibrium position and released. So maksudnya objek ini dia attach dekat spring. Lepas tu dia ditarik sebanyak 20 cm dari equilibrium position. Okey, contohnya sekiranya equilibrium position dia dekat sini, dia ditarik sebanyak 20 cm. Okay, and then lepas dia ditarik pada 20 cm, dia akan di-release. Dan bila di-release, sistem tu akan oscillate vertically lah. And then dia akan fulfill the condition of simple harmonic motion. Okay, kita tengok. If the period of oscillation for the system is 0.75 seconds. So, period dia adalah 0.75 saat. And then bila dia cakap pull down 20 cm from the equilibrium, maksud dia punya amplitude adalah 20 cm. Ataupun 0.02 meter. Alright. Okay, bila objek itu ditarik daripada equilibrium dan dia release. So, maksud dia objek itu dia bergerak dari negative amplitude. Jadi, pergerakan dia akan jadi macam ni. Dari negative amplitude ke equilibrium position. From equilibrium position to positive amplitude. Daripada positive amplitude, dia turun ke equilibrium position. Dan dari equilibrium position, dia kembali ke negative amplitude. Okay. And then, let's look at the first question. Write an expression to describe the motion and determine the position of the object after 1.8 second. So, kita kena tulis dulu expression dan kita kena cari x berapa at 1.8 second. Okay, now. Tapi macam mana nak tulis expression tu? Okay, macam nak tulis expression tu, saya lebih suka, like I taught you, better to draw graph. Draw graph roughly dulu. Okay, draw graph roughly x against t. Okay, now bila objek tu dia akan start, akan ada positive amplitude, akan ada negative amplitude. Objek itu dia akan start dari negative amplitude. Lepas tu dia pergi ke equilibrium. Lepas tu dia pergi ke positive amplitude dan dia kembali ke equilibrium dan finally dia pergi ke negative amplitude. What graph is this? What graph is this? This is negative cos graph. Jadi expression dia akan jadi negative A cos omega t. So, untuk A ni, jadi jawapan untuk A, kita akan compare lah. X equals to negative A cos omega t. Amplitude kita berapa? Amplitude kita adalah 0.2 meter. Cos omega, kita tahu ke tak? Kita tak tahu, tapi kita boleh cari. So, kita tahu period kita. Jadi, omega equals to 2 pi over t. Jadi, 2 pi over 0.75 which will give you 8.38 radian per second. So, ganti awak punya angular velocity dengan 8.38 t. So, this is your expression to describe the motion. Now, kita kena cari x at 1.8 second. Jadi, awak substitute sahaja awak punya time dengan 1.8 second. So, bila awak dah substitute dengan 1.8 second, awak akan dapat satu jawapan, which is 0.16 meter. And please make sure your calculator kena dalam apa bila cari ni? Calculator in mode radian. Calculator in radian mode. Okay, boleh? Okay, we are done with question A. We already know, kita dah cari expression. Inilah expressionnya. Dan kita dah cari position dia after 1.8 second. Iaitu 0.16 meter. Now, we need to sketch the graph of displacement against time. Okay, macam mana nak buat? Okay, tengok balik. So, kita ambil meter dan juga second. So, kita label dulu kita punya amplitude. Amplitude kita adalah 0.2 dan negatif 0.2. Saya guna meter. SI unit will be better. And then, objek tu dia start daripada negative amplitude. Lepas itu, dia pergi ke mana? Dia pergi ke equilibrium position. And then, dia pergi ke positive amplitude, equilibrium position dan negative amplitude. So, awak akan dapatlah graph dia, which is graph negative cos. And you must label your period as well. Jadi, kita tahu period dia dekat sini adalah 0.75. And di sini, bila bahagi 2, kita akan dapat berapa period dia? 0. Awak akan dapat 0.375. So, ini adalah one cycle and then ini adalah one cycle. So, yep, that's all. So, kita dah jawab juga soalan nombor 7B. Question 8. The displacement of a particle performing a simple harmonic motion is given as, so we have this expression, s equals to 12 cos 3 pi t plus 6 pi, where s is in centimeter and time is in second. Okay, question 8. Calculate its displacement and acceleration at time equals to 3 seconds. Okay, let's do A first. So, the question asks for displacement at 3 seconds. Okay, we know this expression, right? So, we just need to substitute the time in this expression. So, x equals to 12 cos 3 pi, and we substitute the time with 3 seconds plus 6 pi. This will give you answer of the answer is negative 12 cm, or x equals to negative 0.12 meter. But you have to make sure your calculator mode is in radian. Okay, now let's look. The second question asks for the acceleration at time. Acceleration at time equals to 3 seconds. You have two ways to find for this. It's either the first way, you use this formula, acceleration equals to negative omega squared times by x. So we know our omega is 3 pi. From this equation is 3 pi radian per second. So, we substitute with 3 pi. We substitute with 3 pi squared. And then the x is the displacement we got from here, which is negative 12. This will give you the answer of 106.592 centimeter per second squared. So this is the first way. But the second way, you have to differentiate twice. Means you have to differentiate this expression twice. So let's differentiate twice. So first we can use the instantaneous velocity formula, which is dx over dt, where you substitute the x, 12 cos 3 pi t plus 6 pi. So when you differentiate this, you will get negative 36 pi sine 3 pi t plus 6 pi. But we have to differentiate twice, right, in order for us to get acceleration. So acceleration, we use the instantaneous acceleration formula is dv dt, and we substitute the v. So d dt, substitute the v, is negative 36 pi sine 3 pi t plus 6 pi, where you will get the, after you differentiate, you will get 108 pi square cos 3 pi t plus 6 pi. And you just need to substitute the t with 3 seconds. So we substitute the t with 3 seconds, which will give you the answer of 1065.92 centimeter per second squared. So you have to weigh. This one is much more easier, but you need to use the x, which you get from the displacement at time equals to 3 seconds. Okay, or the second way is to differentiate twice in order to get the acceleration. Then when you get the expression for acceleration, then you substitute t equals to 3 seconds into that expression. Okay, 8b. For 8b, I'll just do it here. Okay, the period of the oscillation. So what is the period of oscillation? We know we know the angular frequency is 3 pi radian per second. So we know we can find period by using this equation. Angular frequency equals to 2 pi over t. Then just substitute your angular frequency of 3 pi and 2 pi over t. So you will get a period of 2 over 3 seconds. Okay, you will get 2 over 3 seconds, which is the same as 0.67 seconds. So we are done with question A and question B. Okay, now let's look at question number 9. An object oscillate with simple harmonic motion is described by this following expression. So where x and t is in meter and second. What is the amplitude and period of the graph? So we can compare this expression with general equation of simple harmonic motion of displacement in a function of time, which is x equals to a sine omega t. And we know the and then we compare. So x equals to 25 sine 5t. We know the amplitude is 25 meter and the angular frequency is 5 radian per second. Now we're going to look for the period. So we can use this formula, omega equals to 2 pi over t. So where the omega, the angular frequency is 5 and 2 pi and period. So we get the period is 1.26 seconds. So we already find for the amplitude and we already find for the period. Now, sketch x against t graph for the object. So we know x in meter and t in second. And we know the amplitude is 25 and negative 25. And period is 1.26. So you can sketch. 1, 2. Okay. That's all. But don't forget to label your graph, your axis. Okay, we are done with question B as well. So let's look at question number 10. Okay, the position of a particle is given by the expression x equals to 4 cos 3 pi t plus pi, where x is in meter and t is in second. Determine the frequency and period of the motion. Okay, let's do this. So we know our amplitude is 4 meter because you say x is in meter and time is in second. And our angular frequency is 3 pi radian per second. Okay, and we have our phi. Our phi is pi. Our phase constant is pi. Okay, the frequency. So we can find the frequency by using this formula. Omega equals to 2 pi f. And we know the angular frequency is 3 pi equals to 2 pi f, which will give you the answer of 1.5 hertz. And what about the period? And in order for you to look for the period, you can use this formula, f equals to 1 over period. Therefore, period is equals to 1 over frequency, which will give you the answer of, okay, let me calculate this for a while, which will give you the answer of 0.67 seconds. Okay, we're done with A. We already find for the frequency and we already find for the period. Second question, the amplitude of the motion. So we know the amplitude is 4 meter. And the phase constant. The phase constant is pi rad pi. The phase constant is pi. And the position of the particle at time equals to 0.25 seconds. So we know we have this expression from cos 3 pi t plus pi. So we just substitute the t with 0.25 seconds. 0.25 second plus pi. So which will give you the answer is 2.83 meter. But you need to make sure your calculator mode is in radian. Calculator mode is in radian. Yep, that's all for our tutorial question, chapter 1, simple harmonic motion. So if you have any question that you still doubt about, you can ask me. Alright everyone, thank you, bye bye.